Good afternoon. In today's session, we have to see about the interconnection of two-port network. In previous session, we have studied about the two-port network. So, two-port network is nothing but a network containing two pairs of the terminal. We are calling that network as a two-port network because in that network, we are using the two ports. Okay. So here we have seen there are different parameters in the two-port network, Y parameter, Z parameter, ABCD parameter. We are calling that as the transmission parameter. Then there is a hybrid parameter, there is an inverse hybrid parameter. In today's session, we have to study about the interconnection of two-port network for the Y parameter, for the Z parameter, and for the transmission parameter. So here if you see Y parameters are compatible to build the parallel interconnections. If you see in this circuit, I have taken two Y port. These are nothing but the two port network I have taken twice and I am connecting these devices as a parallel. So we can call this device as the parallel two-port network. So if you calculate the Y parameter for this parallel network, you will get the additions of admittance for port 1 plus admittance for port 2. Here we are using port A and port B. So we will get the Y parameter that will be equal to YA plus YB. And if you see if you see for the series interconnections, Z, this is nothing but we are calling as the impedance. So if you see the Z parameters are compatible for the series interconnections. If you see in this circuit, we are taking two Z parameters, ZA and ZB. We are connecting these two ports in series with each other. You can see here we are giving the input separately and other terminal for the input for port A and port B are connected in series with each other. If you see at the output also, we are connecting these one by one. So we can say this is the series combinations. So we can calculate here the impedance for this whole circuit and that will be equal to Z equal to ZA plus ZB. And if you see the transmission parameters are compatible for the cascading. So if you needed the more number of ports can be connected in the cascade, that time you can use the ABCD transmission. So if you are connecting two ports in the cascade format, at that time you will get the transmission for this whole circuit will be TA into TB. We will see one by one how these connections will look like. If you see, firstly we will see about the series connections. And as we know, Z parameters are convenient to make the series connections. So what I can do here, I can take here two port. This is two port. You can see here at port A, there are two terminal at input and the output. You can see here for the port A, incoming current I1 and I1 dash will be the current which will go out of this one. And incoming for the output port for the port A, if you see I2A and outgoing will be I2A dash. If you calculate the voltage drop for the port A, across the input you will get V1A. That will be the voltage which will appear across the input, that is we are calling as a 1, and second terminal we are calling as the output. So output voltage across the output terminal for the port A will be V2A. Then you can see here, now we are supposed to calculate the equations for voltage for these series connections. Here we are studying how two-port networks are connected. So we can see if there are Z parameter, that time we can connect this network in the series combinations. If there is the concept of admittance, that time we can connect Y parameter in the parallel. And if there is a ABCD, at that time we can say that as a transmission parameter and we can connect these in a cascade format. So when we are connecting Z parameters in the series combination, that time we are taking two ports. हम दो पोर्ट ले रहे हैं, उसके बाद what we are doing here, we are making the series connections at input as well as we are making the series connections at the output. You guys can see here also I am connecting series directly. मैंने वायर जो है पोर्ट 1 का आउटपुट को है पोर्ट 2 के आउटपुट को कनेक्ट किया है. And if you see for the input also we are doing the same thing. What we are doing here, we are connecting the input terminal for port 1, we are connecting with the इनपुट ऑफ द पोर्ट बी. पोर्ट ए का जो इनपुट है मैंने वायर से सीधा इसके साथ कनेक्ट किया है. सो व्हाट वी कैन से दिस इज द सीरीज कनेक्शंस फॉर द टू पोर्ट नेटवर्क. Now we know when we are calculating the Z parameter. In Z parameter already we have studied. Voltage will be depend on the values of current. V1 and V2 will be depend on I1 and I2. We have derived these equations for Z parameter, Y parameter, transmission, hybrid, inverse hybrid. Already we have seen this thing. So what we can do here when we are making the series connections for two port network, at that time if you derive the equations for the voltage you will get V1 V2. I am taking in the form of matrix. So you will get the equations V1 V2 equal to voltage that will be across input plus voltage that will be across output. So you will get V1 V2 equal to V1A V2A plus in second matrix you can take V1B V2B. But we know according to Ohm's law V equal to I into R. R is nothing but resistance. You can take here resistance as a impedance because we are calculating here the Z parameter. So what we can do, we can convert the value of voltage in the form of Z and I. So you will get V1A का क्या हो जाएगा, you will get here Z into IA. ZA into IA means what? Impedance across input for port A and impedance across output at port B, that will be ZB. So what will be the equation here? ZA into IA plus ZB into IB. If you are calculating these equations in the form of Z and I, you will get these equations one by one after simplifications. What we can do? We can say here if we know if the components are connected in series, that time the value of current for all these elements will be same or different. Can anyone tell me? Saurabh, are you there? Are you there, Saurabh? Answer the question, please. Okay, you can see here when the elements are connected in series, at that time voltage will be divided and current will be same. I have written here current will be same and voltage gets here divided. Voltage will be divided here. So what we can do here, when there is a series combination, at that time you can see here when there is a series connections, at that time we know if these elements are connected in series, voltage will get divided and current will be same. So what I can do here, I can take IA equal to IB equal to I. So now my equation will become ZA into I plus ZB into I. So I can take I common. So I have written here directly I common and in bracket ZA plus ZB. Z is nothing but impedance across port A, impedance across port B. If you are simplifying these equations and you are converting these equations in the form of matrix, you will get ZA plus ZB into in matrix I1, I2. So here we know current is same for the series connections and voltage get divided. So if you are writing in the form of impedance, you will get V1, V2 equal to Z11 A plus Z11 B, Z12 A, Z12 B. You can convert these equations in the form of voltage equal to current into impedance. So this is the series connections for the two-port network, and we know Z parameters are compatible with the series interconnections. Now we can see here for the parallel interconnection. So we know if we are making the parallel connection at that time we are supposed to use Y parameter because we know Y parameter are convenient to make the parallel interconnection. So if you are making the parallel connection at that time you can see here मैंने क्या किया है if you see here we are making the parallel connection at the input and output. First terminal will be connected to the first terminal. First dash will be connected with the second, first dash of the second port. Again, we are doing the same thing at the output. So what we are doing here, we are making the parallel interconnections for the Y parameter. Now, we know if there is a parallel connection at that time voltage will be same for the parallel component and current will be different. So you can write here equations for the current because we know if there is a Y parameter at that time value of current will be dependent variable and value of voltages will be independent. So you will get the equations I1 and I2 in the form of V1 and V2. And we know when we are making the parallel connections, at that time voltage will be same. So what we can do, we can take here V1 equal to V2. जैसे ये equations लिखे at that time you can write these equations for the current. What will be the equations your I1 I2? यहाँ पे क्या आएगा Y11A plus Y12, Y11A plus Y11B, Y21A, Y21B in this form, and here if you see you will get here V1 V2. So you can see here in the parallel connections for the two-port network, you will get the equations for the voltage, you will get the equations for the current, not for voltage, you will get the equations for the current because in parallel interconnections, voltage will be same. But if you are making the parallel interconnections of the elements, at that time, current will be divided. So you will get here the equations for the current in the form of voltage and the admittance. And we know admittance is the reciprocal of the impedance. So what we can say here, when we are making the interconnections at that time voltage will be same and current gets divided. So here we can calculate the equations in the form of Y because we know Y parameters are compatible for the parallel interconnection. Now we can see here for the cascade. So series parallel connections. If you are making the series and parallel connections for hybrid network, we are not studying here cascade. Cascade में क्या होगा? We can take the cascade as one by one. If we are taking the ABCD parameter, port A, port B, port C, we can connect one by one. मतलब if you see output for the port A will be used as input for port B. But here what will be the difference? If you see output current will be for port A will be IA, that will be outgoing direction. And if you see for the port A, which will be coming the input current, that is nothing but the incoming. So here we have to take that current as a positive, and here we have to take outgoing current as a negative. So when we are making the cascade combinations, we can connect one by one port. And when we are supposed to make the series and parallel connections of the two-port network. You can see here when I am making the series and parallel interconnection, at that time at input you can see we are making the series connections, and at the output port what we are doing, we are making the parallel connection. So you guys can see here when we are taking the series and parallel connections for the two-port network, at that time we are connecting port 1 as a series connections, we are making the parallel interconnections at the port 2. So here you can see here we are making the combined port 2 as the parallel. Now what we have to study, when we are making the cascade connections of the two-port network. What I am saying, when we are making the cascade connection, at that time output of port 1 will be used as input for the port 2. Means V2 and V3 will be same, and this I2 and I3 will be same, but what is the difference? Directions of the current, because it is the outgoing current for port 1 and I3 is the incoming current for the port 2. So we know when we are making the cascade connections, ABCD or transmission parameters are compatible. So what we can do here, Yogita, please mute yourself. So here you can see when we are making the cascade connections for the two-port network, at that time we know we can use the transmission parameters. We can use the ABCD parameter. So here when we are making the transmission port for the cascade combination. At that time, design of, if you see here, I have given the one example, design of higher order filter. So we can use here third order that can be designed with the cascade combination of first and second order filter for the multi-stage amplifier to achieve the desired gain. So here what we can do, we can use here first and second order filter to make the higher order. So it means what? Here we can use two port, and by cascading these we can design the third order multi-stage amplifier. So here if you see in this circuit what I have used, I have taken here two port and I am connecting this port in the form of cascading. Here you can see we know when we are using the transmission or a ABCD parameter, at that time voltage and current for the port 1 will be depend on the voltage and current for the port 2. Already we have seen these things in the पैरामीटर्स विच वी आर यूजिंग इन द टू पोर्ट नेटवर्क। हमने ये सब देखा है कि जेड पैरामीटर में वोल्टेज डिपेंडेंट होता है, बिकॉज वी नो व्हेन वी आर यूजिंग द टू पोर्ट नेटवर्क एट दैट टाइम देयर इज रिक्वायरमेंट इज व्हाट, टू वेरिएबल्स विल बी डिपेंडेंट। क्या होता है वहां पे, दो जो वेरिएबल होते हैं वो डिपेंडेंट होते हैं। सो व्हाट वी कैन से हियर, व्हेन वी आर मेकिंग द cascade combination, at that time here if we are taking the two port, हमने क्या किया है, it is also a two port, it is also a two port because it is having, this is one terminal, this second terminal, it is having two terminal, it is also having the two terminal. I am giving the output of port 1 to the port 2 as a input. So here if you calculate the equations for the port 1, you will get V1 I1 equal to transmission into V2 minus I2, because we know this current is the outgoing from this port. So we are taking here minus I2. And if you are calculating for this port, ये जो second port के लिए, if you are calculating, so we know here for port 2 input will be V3 and I3. So what we can say here, V3 and I3 will behave as a dependent variable and this will be dependent on V4 and I4. So what we can say here we can calculate V3 I3 equal to transmission for this. So here तुम क्या लिख सकते हो यहाँ पे, you can take 2 by 2 matrix and you can take here T11 T12 T21 T22. मैंने यहाँ पे सिर्फ I have taken one constant as a T2. So you can use here matrix also. So you can take here V3 I3 equal to T2. In matrix you can take V4 and minus I4. So you, if you are solving these equations, you will get here V1 I1 equal to T1 T2 V4 minus I4 if you are combining these equations. And what we are saying here, V2 equal to V3 and minus I2, that will be equal to I3 because I3 is incoming here if you see at this node, and here if you see for this port I2 is outgoing, that's why we are taking as the minus I2, and for this port I3 is incoming, so we are taking it is as the positive. So here we can calculate the value for the transmission by using the matrix multiplications. We can do this matrix multiplication and you will get the equations for the transmission. Here we have finished about how to make the interconnections for the two-port network. So we can make parallel interconnections that can be used for the Y parameter. We can use series interconnections by using the Z parameter because Z parameter are compatible for the series interconnections. Kamla, Yogita, are you there? Kamla, Yogita, are you there? हाँ, कमला, your voice is not coming. तुम्हें मेरा आवाज अच्छे से आ रहा है? Am I audible? हाँ, okay, okay, okay. Please mute yourself. Okay. Uh, my class uh, was started at 1:45 and you are joining now. There is no use of. हाँ, okay, हाँ, योगिता, you are also doing the same things. Class जब मतलब शुरू होता है, at that time you guys are supposed to join the class. Okay, so here we can see here Y parameters are compatible for this parallel combinations, means parallel interconnections. If we are supposed to make series interconnection, at that time we can use Z parameter. And if we are supposed to use the cascade interconnections of the two-port network, at that time we can use the transmission or the ABCD parameter because these are compatible for the cascade. So here now we can see our next unit is nothing but firstly, we will see the some applications of these parameters. Parameters means what? Here we are using the parameters as hybrid parameters. Then we are using impedance parameter, we are calling as the Z. Admittance parameter, जिसको हम Y parameter बोलते हैं. Then we can use here ABCD parameter, जिसको हम transmission बोल सकते हैं. Or we can say we can use inverse transmission or the inverse hybrid. Or inverse इनवर्स इम्पेडेंस इज नथिंग बट द एडमिटेंस. हम इनवर्स इम्पेडेंस को ही क्या बोलते हैं? एडमिटेंस बोलते हैं. सो हियर यू कैन सी when we are doing the circuit analysis of two port network, that time we can use the Z parameter, Y parameter, transmission parameter. So these parameters are used to do circuit analysis of the two port network. Then if we are using the small signal BJT amplifier, that time also we can make the use of hybrid parameters. We have already studied these things in the electronic circuit. हम जो फर्स्ट यूनिट हमने देखा है मॉसफेट का, in that we have studied about the small signal model. At that time what we are doing, small signal MOSFET amplifier we have seen. At that time what we are doing, we are supposed to calculate the equations for the current. At that time we are making that amplifier in the form of hybrid circuit, hybrid model, and we are using the hybrid parameters to calculate the equations, to derive the equations for the current. So what we can say, this is the applications of the Y parameter. We can use H parameters in the small signal BJT amplifier. If you see here, we can say we can calculate the values of the hybrid model. So HIE we are calling as the input impedance. HFE we are calling this is as the forward current gain. We can calculate these values in this form of voltage and current because we know according to Ohm's law V equal to IR. So you will get H is nothing but impedance. So R equal to V by R. So you can take here hybrid. This is nothing but the H parameter equal to V by R. So H11 we can take as the V1 upon I1, and at that time we are making V2 equal to 0 because we are taking second port as the short circuit. So what we can say, when we are using the H parameter in the small signal BJT amplifier, at that time we can say we can calculate the values of input impedance. We can calculate the values for current gain. We can calculate the value for the output admittance in this way. If we are making the cascade combinations of the two-port network in the multi-stage circuits, if you are making the oscillators, if you are making the multi-stage filter, multi-stage amplifier, at that time you can use here ABCD parameter or the transmission parameter. If we are supposed to find the transfer function for the given network, that time we can use the parameters to derive the transfer function for that network. So these are some applications of the parameters. We can use these parameters in the BJT amplifier, multi-stage amplifier. You can use this amplifier to calculate circuit analysis to derive the transfer functions. Now we are supposed to study the Laplace transform function. So Laplace transform, if you see, a French astronomer and the mathematician first presented the Laplace transform, and his name is Pierre Simon Laplace. He has derived these equations of the Laplace in 1979. So Laplace transform is nothing but it is the method for the differential equations because it is offering advantages over the classical method. If you see, Laplace transform is the internal transformation. Transform means what? It will transform. So it can transform a function from time domain to the complex frequency domain. It means in shortcut you can say Laplace transform. We can use the Laplace transform to convert the value from time domain into the frequency domain. If you see, if we are having the value as f of t, we can convert that value in the form of frequency. So if you see, we will get the equation as L is nothing but used for the Laplace. F is nothing but for frequency and T is nothing but time domain. So you can convert this time domain into the frequency domain. तो यहाँ पे time है तो frequency में तुम क्या ले सकते हो यहाँ पे when we are using the Laplace transform at that time instead of time you will get the equation in the form of frequency and you can take these equations in the form of derivation. You can take the value as yes. तुम यहाँ पे if there is dv by dt you can take here yes. If there is d2y by dt square at that time you can take yes square. So here we can use the value in the frequency domain as a yes, and if you are calculating that value, that is nothing but the complex variable because we are saying it is converting the value from time domain into the complex frequency domain. So you will get that value in the complex variable. So we can take S equal to sigma plus j omega. This is the symbol for sigma. And here as the imaginary value is coming, this is we are calling as the complex variable. So you will get here S equal to sigma plus j omega. And when we are using the Laplace transform, at that time we are converting the value of time domain into the frequency domain, and you will get L of f of t equal to f of s equal to 0 to minus infinite integration for f of t into e to the power minus s of t dt. This is the standard formula for the Laplace transform. So here we can say Laplace method is used to solve differential equations here specifying the performance of the complicated network. The solution to such problem is time consuming, so we can use the Laplace transform to get solution in a systematic way, to get a solution in the systematic way. Because by using the Laplace transform, here we are using the initial conditions that can be used in the transformation equation. So when we are using the Laplace transform, at that time we can convert differential equation to the frequency domain. We can convert Laplace transform that will be in the form of differential equation, but here you will get the value in the form of frequency domain. And if you see here, independent variable is as a complex frequency. S is nothing but it is the complex frequency. So here we can say yes, we can use as the differentiation, and the integration in the time domain are transformed into the algebraic operations. So here we can say by using the Laplace transform, you will get the solutions that is obtained by simple algebraic operations that will be in the frequency domain. So by using the Laplace transform, we can convert the value of the time domain into the frequency domain. Here we can say I have given here the some functions which we are using. We are using the impulse, we are using the ramp function, we are using the sinusoidal, we are using the exponent. So these functions are we are taking in the form of time domain. हम क्या कर सकते हैं frequency को we can take this ramp function, we can take this exponent function on the y-axis, on x-axis we are taking the time. So we can convert these equations in the form of frequency domain by using the Laplace transform. So I have given here the some functions which we are taking in the time domain. And when we are converting this time domain value into the frequency domain by using the Laplace transform, you will get this value. So we are supposed to see how we will get this value. Because when we are using the derivation, जैसे if you see what we are doing when we are doing the Laplace transform, at that time if you see we are considering s as the differentiation and the integration, because when we are converting the time domain into frequency domain, we are taking here initial conditions and we are considering these initial conditions to derive the value for the integration. हम क्या कर रहे हैं यहाँ पे इंटीग्रेशन ले रहे हैं in this way. जैसे तुम डेरिवेटिव लेते हो, जैसे इंटीग्रेशन लेते हो, जो वैल्यूज तुम्हें मिलेगा बाय पुटिंग दिस फंक्शंस हियर. जैसे हम यहाँ पे एफ ऑफ टी है, यहाँ पे इफ यू आर पुटिंग हियर यू ऑफ टी, if you are putting here u of t, this is as the step up function. If you are putting here u of t, what will be equation? You will get L f of t equal to f of s equal to 0 to infinite u of t into e to the power minus st dt. So u of t is nothing but it is the constant term. It will get as it is. And e of minus st इंटीग्रेशन, वी नो e ऑफ माइनस एस टी का इंटीग्रेशन क्या होता है? माइनस एस ऑफ टी अपॉन यस अपॉन एस माइनस यस. So what will be the value? E to the power minus st minus yes upon minus yes. We know we are supposed to take these values as a लिमिट. जैसे हम ये इंटीग्रेशन में है, वैसे ही जब तुम इसका इंटीग्रेशन डिराइव करोगे तो व्हाट वी आर सपोज टू डू, वी आर सपोज टू टेक दिस एज द वैल्यूज फॉर द इंटीग्रेशन. So minimum value is 0 and maximum value is infinite. We are taking e to the power minus st. So if you calculate e to the power minus st by minus s for 0, firstly you will calculate for infinite, that minus 0. If you calculate for infinite, that value will get as a 0. If you will calculate for 0, you will get a to the power minus s into 0, that will be 1 upon yes. Yes, we are having as it is here also, so you will get value as a 1 by s. In this way we are supposed to solve for all this. We can see these things in the next class. Laplace transform हम फिर से we will see in tomorrow's lecture. I have given here some example how to solve. We will study these things in the next session. Okay, now firstly I will take your attendance. So in today's we will revise our today's session. In today's session, we have studied about the interconnections for the two-port network. We know why parameters are compatible for the parallel interconnections. Z parameter are inconvenient for the series interconnections, and the ABCD parameter are the convenient to make the cascade combinations. Then, if you see how we can make the series interconnections for the two-port network by using the Z, we can see here we can make the parallel interconnections for the y parameter. Here if you see, voltage will be same but current can be get divided, because here we are making the parallel interconnections for the y parameter. And when we are making the series parallel combination, at that time what we are doing here, we are doing here series combinations. And at the output for port 1 and port 2 we are making the parallel interconnections. If we are making the cascade combinations for the two-port network, we can make cascade combinations by using the transmission parameter, or we can use here the ABCD parameter. And you will get values for the V1 and I1 in the form of transmission for port 1, port 2 into output voltage across the last port. Here we are making the cascade connection for two port. We are taking two port. So यहाँ पे last क्या है? Second port. So here you will get value as T1 into T2 into V4 minus I4. We are taking I4 minus because it is outgoing current from the port 2. This is the output voltage. Then Laplace transform. So the Pierre Simon Laplace has discovered about the Laplace transform, and it is the application to the differential equation. It is derived in the 1979. Laplace transform is the integral transformation of the function f of t from the time domain into the complex frequency domain. So we can use the Laplace transform to convert the value of differential equations from time domain into the frequency domain. If you are calculating the equations, you will get L f of t equal to f of s integration of 0 to minus 0 to infinite f of t e to the power minus st dt. So if you see, s is nothing but this is used as the independent variable, which is the complex frequency. And here we are using the differentiation and integration because we are transforming the value that are in the time domain. We are converting that value from time domain into the frequency domain. So we can take s as the complex variable. We can take sigma plus j omega. This is the value as a frequency variable. Remaining syllabus we can see in next class. You guys can leave now. Thank you. If anyone is facing any issue, you can ask me.